So we have been talking for a little while about different transformations. We've talked about translating, reflecting. We've talked about maybe stretching or shrinking a graph or a figure. And all of that has been leading up to our quadratics unit. And in this first video, I'm just going to continue talking about graphs. Okay? So in this unit, we're specifically talking about quadratic functions. And a quadratic function is a function in the family of y equal to x squared. Okay? The equation could be a lot more complicated than that. It could have negatives in it. It could be adding or subtracting numbers. It could have a variety of different things going on. And in a little while, in a later video, and later on in class, you'll see some different ways that this equation can be changed. And we've done a little bit of that so far. But basically, any time that you have x squared as your largest coefficient, it's going to be a quadratic function. Okay? And any time that you graph a quadratic function, it's going to be in the shape of a parabola. Okay, and we've seen several examples of this so far. A parabola, I'd like you to draw this into your notes, looks like a U. It's either going to go opening up or opening down. Okay, and that shape is called a parabola. Just like a linear function, it's called a line. This is just a new vocabulary word for this U shape in math. Anytime we have a quadratic function, it makes a parabola. Okay, so on our parabola, there are lots of different things that you can think about. Okay, in a parabola, you can define the vertex, which we've talked about. That's where the parabola changes direction. It's usually the maximum or minimum point, the vertex. I'm going to skip number 2 and come back to it. The third one, we can talk about the direction, whether it opens up or it opens down. So that means whether the opening is at the top or the opening is at the bottom. And then the scale factor. This is how much it is stretched or shrunk. Okay? That's the number that it's multiplied by. Okay? That's what the scale factor is. And then the very last thing, which we haven't really seen yet so far in this unit, is the roots or the zeros. Okay? I would say that this is equivalent to the y-intercept for a line. So when we're graphing a line, one of the most important points that you use is you use the y-intercept to tell you where to graph that line. In a parabola, the two most important points are called the roots, and they're also called the zeros. These two words, when you're talking about a parabola, these two words mean the same thing. Okay? And this word, roots or zeros, is where the parabola crosses the x-axis. So, where y equals 0. So in a line, this is, we look at where the line crosses the y-axis. In a parabola, we think about where the two places where it crosses the x-axis. So if I'm looking at an example, the vertex is the minimum point in this example. Okay, so the vertex of this parabola is 5, -2. Okay, I'm looking for the roots or the zeros. In other words, I'm looking at where y equals 0. So I'm looking along this horizontal line. So that would be this point and this point. And actually, let me go ahead and color code it for you. So the roots, or the zeros in this case, are 4, 0 and 6, 0. So those 2 points where y is 0 on our graph. The direction, so when I'm talking about the direction, I want to know whether it's opening up or opening down. Okay, so I want to think about where the opening is. In this case, we have our vertex as the minimum, so it opens at the top, so that means that it opens up. The opening is up at the top. And then I want to think about the scale factor. Okay, this is going to be one of the most difficult things to figure out, and we've done a little bit of this so far when we talked about transformations. Okay, so what I'm going to do is I'm going to look at a couple different points here. Okay, so I'm going to look at the vertex to start off with. So I know that the vertex is here. And then what I'm going to do is I'm going to search either to the left or the right. It doesn't matter which way. In this case, I like to look to the right. And I'm going to look for the next nice point. Okay. In this case, it is right here at the root of 6. Okay. And I'm going to look at the rate of change, meaning the slope or the change in x and the change in y between those points. And what I can see is that from the vertex to the next nice point, the change in x and the change in x is 1, and the change in y is 2. All right? And let me find another nice point. So I'm going to keep looking all the way up until I find my next nice point. So if I look at that change, the change in 2 goes all the way up 8. So the change, if I change 2x, I change by 8 in my y. And I want to compare that to my original, my parent function. So if I'm looking at the parent function of y equals x squared, normally I have 0, 0, 1, 1, and 2, 4 as my points. So normally a change of 1 in the x, a change of 1 in the x gives me a change of 1 in the y. And a change of 2 in the x gives me a change of 4 in the y. Okay, so what I want to look at is I want to look at how these numbers compare to these numbers. Okay, so when on our original, a change of 1 gives us a change of 1 in the x and y. In this case, in our new one, a change of 1 gives us 2 on our next graph. In this case, in our original, a 2 gives us a change of 4, and in the new one, a change of 2 in the x gives us 8. And so what I notice is that the y's are changing double the amount that they did in the original. So what that means is that my scale factor for this graph is a 2. Okay, so what I want you to do is I want you to think about this question. You might not know the answer right away. I do not want you to look it up online or in your book. I do not want you to ask anybody else. I want you to think about the answer to this question. How do I find the vertex of a parabola if I know the roots? For example, in the graph of the parabola for y equals 2x squared minus 12x plus 16, the roots, or zeros, are 2 and 4. What is the vertex? So if I were to graph that, remember that roots are 2 and 4 means that those are the two places it crosses the x-axis. So that means that when y is 0, x is either 4 or 2. So I want you to think about how you might find the vertex for this graph. And you might try this example first. If you can figure out that, then I'd like you to, in general, talk about how to find the vertex if you know the roots. Bring that to class with you next time.